Hi guys, so I wanted to show you guys a fun little game, and this is how you get to it. You go to course catalog and you scroll down, and it's in the hour of code, and it's called OWL for Oceans. So it just talks about how computers learn to code, and it's a really fun, cute little game. So we're gonna watch the video and then we'll play the game together.
My name is Ale Flores, and I'm a product manager at Alexa.
My name is Dr. Chelsea Haupt. I work at the Allen Institute for Artificial Intelligence, and I work on an AI-powered academic search engine. All around you, computers are making decisions, and those decisions affect your daily life. When you do an internet search or scroll through your newsfeed, computers decide what you see. Computers can already recognize your face and understand your voice. And soon they'll be driving cars and detecting diseases even better than humans. So how is any of this possible?
You may have heard about something called AI, or artificial intelligence. True artificial intelligence is decades away. But there's a type of AI called machine learning that is here today. It's a type of AI you probably interact with every day without even knowing it. And it has the opportunity to help us tackle some of the world's biggest challenges.
Machine learning is how computers recognize patterns and make decisions without being explicitly programmed. What's so exciting is that it's a completely different way to program a computer than what we've ever done before. With machine learning, instead of programming a computer step by step, you can program a computer to learn just like you learn, through trial and error and lots of practice.
Learning comes from experience, and that's true for machine learning too. In this case, experience means lots and lots of data. Machine learning can take in any kind of data, images, video, audio, or text, and begin to recognize patterns in that data. Once it learns to recognize patterns in the data, it can also learn to make predictions based on those patterns, like noticing the difference between an image of a car and an image of a bicycle.
AI and machine learning are playing a bigger and bigger role in society at large and shaping all of our futures. That's why it's so important to learn how it works with some hands-on experience. You're about to get the chance to train your own machine learning model. Remember, AI is like any tool. First you get the knowledge, then you get the power.
All right. So in this, you are going to train the robot to distinguish what are fish and what are not, and what belongs in the water. So if you can't read, it says garbage dumped in the water affects marine life. In this activity, you will program or train AI, artificial intelligence, to identify fish or trash. Let's clean up the ocean. Click anywhere on the screen to continue. Let's meet AI. There he is. AI does not know if an object is a fish or trash, but it can process images and identify patterns. To program AI, use the buttons to label an image as fish or not fish. The training you provide will teach AI to recognize patterns on its own. So let's get started. So you're going to click no, not a fish if it's not a fish, or fish if it is a fish. Is that a fish? Nope. 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 Did you know 17 billion pounds of plastic enter the ocean every year? You are programming or training AI with each click. Keep going. That is not a fish. Fish. Not a fish. Not a fish. Not a fish. 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 Nope. Yep. Says 80% of ocean pollutions come from land debris and is estimated to cost 13 billion per year. AI learns from your choices. If you make a wrong choice, AI will repeat your mistakes. Keep training. So if you accidentally click yes, he will definitely think that that is a fish. So just go through for a while until you're done, or until it'll actually go forever. So it's saying great work. The more data you provide AI, the more it learns. Keep training AI or continue when ready. So you can keep going through if you choose, or you guys can click continue, which is right here. It says, now let's see if AI knows what a fish looks like. AI will analyze a random set of objects and label them based on your training. Let's go. How'd we do? I think we did pretty good. It's okay if we messed up and one trash accidentally got in there because we can help keep training him. So let's keep going. Based on your training, here are some objects that AI identified as fish. How did AI do? Do you guys see any trash? Yep, we have one light bulb. It says click here to switch between objects identified as fish and not fish. You can train AI more or continue. So we can go back and train him some more, and that will get rid of the light bulb, or we can hit continue. I'm going to hit continue because I feel like we did pretty good. So far, we trained AI to identify objects as either fish or not fish. What if this data was used to decide what belonged in the water? What would happen to the other sea creatures? Does our training approach cause unintended consequences? Let's see. So they want to see if the way we train him is going to have consequences. Let's see what happens to all the other sea creatures. Oh dear. Did you notice that AI identified some sea creatures as not fish? While these sea creatures are not fish, they do belong in the water. AI only learns what we teach it. Let's train AI again. Let's teach AI to learn which objects should be in the water. Does a snail belong in the water? Yeah. What about a cup? No. Light bulb? No. Octopus? Yes. Fish? Yes. This says, in the oceans, plastic debris can harm fish, seabirds, and marine mammals. Protecting seabirds and marine life is one of many reasons to keep the ocean clean. The more training data you provide, the more AI learns to keep training. Does that belong in the water? Nope. Yes. 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 So this is just like before. You can go through endlessly, or you'll be able to hit continue. Marine plastic pollution has impacted at least 267 species worldwide, including 86% of all sea turtles. How sad. Keep training him to see what belongs in the water. A dolphin. Forks definitely don't belong in the water. So you can keep going, or let's do 5 more and then we'll hit continue. 1, 2. It says, great work. The more data you provide, the better he'll do. Keep training, or click continue. 3, 4, and 5. Well, let's do the starfish. Let's hit continue now. All right. It says, do you think AI will now do a better job identifying what should be in the water? Let's watch. Let's run it and let's see. What is he doing? Yikes. We did not click those. All right, so based on your training, here's what he thinks belongs in the water. How did he do? He did terrible. So we can hit train more or hit continue. I'm going to hit continue, but you guys can go back and train him some more if you would like. We're gonna watch another video.
Machine learning is only as good as the training data you put into it. So it's super important to use high-quality data, and lots of it. But if data is so important, it's worth asking, where does training data come from? Often, computers are collecting training data from people like you and me without any effort on our part. A video streaming service might keep track of what you watch, then it can recognize patterns in that data to recommend what you might want to watch next. Other times, you're directly asked to help, like when a website asks you to spot street signs and photos. You're providing training data to help a machine learn to see, and maybe even one day drive. Medical researchers can use medical images as training data to teach computers how to recognize and diagnose diseases. Machine learning needs hundreds and thousands of images and training direction from a doctor who knows what to look for before it can correctly identify disease. Even with thousands of examples, there can be problems with the computer's predictions. If X-ray data is only collected from men, then the computer's predictions may only work for men. It may not recognize diseases when asked to diagnose the X-ray of a woman. This blind spot in the training data creates something called bias. Biased data favors some things and deprioritizes or excludes others. Depending on how training data is collected, who is doing the collecting, and how the data is fed into the computer, there is a chance that human bias is included in the data. By learning from biased data, the computer may make biased predictions. This can happen whether the people training the computer are aware of it or not. So when you are looking at training data, ask yourself 2 questions. Is this enough data to accurately train a computer? And does this data represent all possible scenarios and users without bias? This is where you, as the human trainer, can play a crucial role. It's up to you to give your machine unbiased data. That means collecting tons of examples, often from lots of different sources. Remember, when you pick and choose data for machine learning, you're actually programming the algorithm using training data instead of code. The data is the code. The better the data you provide, the better the computer will learn.
All right, let's keep going with AI. We're almost finished. It says artificial intelligence and machine learning can be used to teach a computer new patterns. So right here, you get to select what type of fish do you want to train AI to detect. Rectangular fish, circular, triangular, green, red, or blue. I'm just going to pick blue. You guys can pick whatever you would like though. Let's teach AI a new word by showing it examples of that type of fish. Is that a bluefish? Nope. This? No. 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 That's kind of bluish purple. Not quite sure if there's blue. That has blue on it, but he's not a blue fish. Do you think he has enough data? You can click to continue to find out. So we really haven't trained him very much, but we can totally click and see if he has enough knowledge to rule bluefish or not. Let's hit continue. With your training, you've programmed him to recognize bluefish. Let's see AI identify bluefish. Let's see. Ah! Do you guys feel like we gave him enough training? He's doing okay. And it will keep running through. So then let's hit continue. Based on your training, AI identified these fish as blue. How did he do? You can train him with more training right here if you did not like those results and you want to improve, or you can hit continue. I'm going to hit continue. Click on the info button to see what AI learned. Okay, so these were the most important fish parts: the colors, the body, the eyes, the dorsal fin, and tail. Click individual fish to see their information. All right, we have one more video. Let's watch it.
AI and machine learning can affect every part of society. For instance, self-driving cars use AI to recognize their surroundings, track objects, and make super important decisions, like when to stop. Machine learning is already being used in some really amazing things. It's allowing us to be more energy efficient. We use it to improve how we grow food and manage natural resources. It's dramatically changing how we diagnose diseases and create new medicines. It's even helping the blind see.
I think it's a man jumping in the air doing a trick on a skateboard.
But there are also risks. Consider the potential impact when machine learning is used to evaluate candidates for college admission, screen applicants for bank loans, or even predict crime or spot criminals. When using machine learning in these types of applications, we need to make sure not to use prejudiced training data that would perpetuate human bias.
As AI and machine learning change everything, it's important that you have a hand in how they're being used. More than any other technology, AI has the potential to revolutionize our lives for the better, so long as it's done in a way that avoids bias that could cause harm or inequity. The most important thing about machine learning is human learning. Knowing how this technology works is the first step on your journey to using it for good.
All right. So here you're going to teach AI a less obvious word. So you guys can pick one word: delicious, glitchy, silly, fierce, angry, happy, wild, spooky, endangered, fun, scary, playful, hungry, fast, or awesome. Let's do a spooky fish since it's almost Halloween. Let's teach AI a word that depends on your opinion. It's up to you to pick the fish that matches your word. We're doing spooky. Is he spooky? He's a little spooky. I'd be scared if I saw that fish. He's not spooky. Yikes. Is it fair to use artificial intelligence to judge a fish by its looks? While AI might seem fair and neutral, its analysis comes from the training we provide. What unintended biases could this cause? So, you might not think this fish is scary and your mate or spooky and your neighbor might. And so right now I'm training him to only pick the fish that I feel are spooky. And so it's biased because it's only based on my opinion. If they have sharp teeth, I'm definitely saying they're scary. Spooky. No. So keep going while you guys do this. And you can do this as long as you want. The longer you do this, the more training he gets. But I'm going to click continue. All right, he's going to use what I've programmed him to do to recognize spooky fish. Let's see. I think he needs more training, but we're going to hit continue. So he identified these as spooky fish. You can train more, or you can hit finished, or you can teach him another new word. But I'm going to hit finish. And so you can see how my perception of what fish was spooky versus what was not spooky can change the outcome of what you program your little computer or robot to do. So I hope you guys had fun today. You can type in your names right here if you choose and hit submit, and then you can print out that you've completed an hour of code. I hope you guys had fun doing that. I'll talk to you soon. Bye.